structure of a blockchain. Transaction is the basic element of the Bitcoin blockchain. Transactions are validated and broadcast. Many transactions form a block. Many blocks form a chain through a digital data link. Blocks go through a consensus process to select the next block that will be added to the chain. Chosen block is verified and added to the current chain. Validation and consensus process are carried out by special peer nodes called miners. These are powerful computers executing software defined by the blockchain protocol. Let's now discuss the details of a single transaction. In Bitcoin, a fundamental concept of a Bitcoin network is an unspent transaction output, also known as UTXO. The set of all UTXOs in a Bitcoin network collectively define the state of the Bitcoin blockchain. UTXOs are referenced as inputs in a transaction. UTXOs are also outputs generated by a transaction. All of the UTXOs in a system are stored by the participant nodes in a database. Now let's review the role of the UTXOs in a Bitcoin blockchain. The transaction uses the amount specified by one or more UTXOs and transfers it to one or more newly created output UTXOs, according to the request initiated by the sender. The structure of a given UTXO is very simple. It includes a unique identifier of the transaction that created this UTXO, an index or the position of the UTXO in the transaction's output list, a value or the amount it is good for, and an optional script, the condition under which the output can be spent. The transaction itself includes a reference number of the current transaction, references to one or more input UTXOs, references to one or more output UTXOs newly generated by the current transaction, and the total input amount and output amount. Participants can validate the transaction contents. Does the UTXOs reference the input exist in the network state? This is the only one of the many validation criteria. Recall our demonstrated scenario. This is similar to Amy asking Kevin to verify the money in the envelope to be $10,000. Are these UTXOs valid? All right, it is time to explore a real transaction. It is available at this link. At the top left is the transaction number. Just below, there are 3 input UTXOs referenced, and an arrow points to the references of the 2 output UTXOs. Note that there are 3 input UTXOs and only 2 output UTXOs. This means that the total amount in 3 input UTXOs are spent to generate 2 new output UTXOs. Just below the output UTXOs is a total amount transferred in the Bitcoin value. That is shown in green. Let's now move on to learn about a block. As you can see, a block is composed of a header of information about the block and a set of valid transactions. At first, we'll examine the Genesis block. It's available at this link. We introduce this block number 0 for posterity's sake. This is where it all began. Satoshi Nakamoto initiated the Bitcoin blockchain with one transaction of 50 Bitcoins or 50 BTC. This one transaction created a UTXO output for Hal Finney's address. The date of the blockchain creation is January 3rd, 2009. There was no previous block. This field is all zeros. It also lists a block reward or miners fees of 50 BTC. We'll discuss miners reward in a later lesson. Let's now look at the more recent block, 482808. On the right panel, note the current block hash. The previous block hash, that is a link to the previous block, and on the left panel, down here, the nonce. You will learn about the block hash computation in the module quiz and in the later lessons. Now let's look at the structure of the blockchain by peeking into the Bitcoin blockchain. Our goal is to understand the link between the blocks. Let's consider the chain of 3 blocks. 488-867, 488-868, 488-869. 488-868, shown in the middle, has the hash of 488-867 as its previous hash. Block 488-869 has the hash of 488-868 as its previous hash, forming the links in the chain. To summarize, transactions bring about transfer of value in the Bitcoin blockchain. The concept of UTXO defines the inputs and outputs of such a transaction. Once a block is verified and algorithmically agreed upon by the miners, it is added to the chain of blocks, namely the blockchain. Now that we have reviewed the basics of a blockchain and its basic structure and origin, let's consider the basic operations in a blockchain. Operations in the decentralized network are the responsibility of the peer participants and their respective computational nodes. For example, laptop, desktop, and server racks. These operations include validation of transactions, gathering the transactions for a block, broadcasting the valid transaction in the block, and consensus on the next block creation, and chaining the blocks to form an immutable record. In this lesson, we explore some of the fundamental operations of the Bitcoin blockchain. First, we have to discuss the participants. There are two major roles for the participants. Participants that initiate transfer of value by creating a transaction, additional participants called miners who take on added work or computation to verify transactions, broadcast transaction, compete to claim the right to create a block, work on reaching consensus by validating the block, broadcasting the newly created block, and confirming transactions. You might wonder why participants would take on additional work. Well, the miners are incentivized with bitcoins for their efforts in managing the blockchain, as we'll find out. Transaction validation is carried out independently by all miners. The process involves validation of more than 20 criteria, including size, syntax, etc. Some of these criteria are referenced input unspent transaction output UTXOs are valid. Recall, UTXOs were defined earlier in lesson 2. Reference output UTXOs are correct. Reference input amount and output amount match sufficiently. Invalid transactions are rejected and will not be broadcast. All the valid transactions are added to a pool of transactions. Miners select a set of transactions from this pool to create a block. This creates a challenge. If every miner adds the block to the chain, there will be many branches to the chain, resulting in inconsistent states. Recall that blockchain is a single, consistent, linked chain of blocks. We need a system to overcome this challenge. The solution? Miners compete to solving a puzzle to determine who will earn the right to create the next block. In the case of Bitcoin blockchain, this puzzle is a computational puzzle and is central processing unit or CPU intensive. Once a miner solves the puzzle, the announcement is broadcast to the network and the block is also broadcast to the network. Then other participants verify the new block. Participants reach a consensus to add a new block to the chain. This new block is added to their local copy of the blockchain. Thus, a new set of transactions are recorded and confirmed. The algorithm for consensus is called proof of work protocol, since it involves work or computational power to solve the puzzle and to claim the right to form the next block. Transaction 0, index 0 of the confirmed block, is created by the miner of the block. It has a special UTXO and does not have any input UTXO. It is called the coin-based transaction that generates the miner's fees for the block creation. Currently, the miner's fees is 12.5 BTC for Bitcoin. This is how new coin is minted in Bitcoin. To summarize, the main operations in a blockchain are transaction validation and block creation with the consensus of the participants. Yet, there are many underlying implicit operations as well in the Bitcoin blockchain. Let's now look beyond Bitcoin. Bitcoin blockchain is open source and the entire code is available on the GitHub. During the initial years beginning roughly in 2009, this open source code was extended to release different cryptocurrencies. About 300 plus cryptocurrencies were introduced. Bitcoin supports an optional and special feature called scripts for conditional transfer of values. Ethereum Blockchain extended this scripting feature into a full-blown code execution framework called smart contract. A smart contract provides the very powerful capability of code execution for embedding business logic on the blockchain. Based on such capabilities, three major types of blockchains emerge from Bitcoin Foundation. Type 1 deals with the coins and cryptocurrency currency chain, example Bitcoin. Type 2 supports cryptocurrency and a business logic layer supported by code execution, example Ethereum. Type 3 involves no currency but supports software execution for business logic, example the Linux Foundation's Hyperledger. With the addition of code execution comes the serious consideration about public access to the blockchain. Hence the classification of public, private, and permission blockchain based on access limits. We have been watching Bitcoin blockchain continuously operational since its inception, all supported by its public participants. Thus, Bitcoin is a fantastic example of a public blockchain class. Anybody can join and leave as they wish. Transaction blocks in the blockchain are publicly observable, even though participants are anonymous. It is open source. You can also create new coin digital currency by modifying the Bitcoin code. Wallet applications provide the basic interface to transfer value through the Bitcoin blockchain. In a private blockchain, access to the blockchain is limited to selected participants. For example, those participants within an organization. This restriction helps in simplifying the normal operations such as block creation and consensus model. The third classification of blockchain is permission blockchain, also called consortium blockchain. It is meant for a consortium of collaborating parties to transact on a blockchain for ease of governance, provenance, and accountability. For example, a consortium of all automobile companies or healthcare organizations. Permission blockchain has the benefits of a public blockchain, with allowing only users with permission to collaborate and transact. In summary, significant innovations such as smart contracts have opened up broader applications for blockchain technology. Private and permission blockchain allow for controlled access to the blockchain, enabling many diverse business models.